Good morning, everyone. You're welcome to today's live. So, we are moving on to a new topic today. So, we're going to get started. Good morning, good afternoon, good evening, irrespective of your geographical location. I welcome you to my live session this morning. Welcome, welcome. Guys, help me support this live. Keep tapping on your screen. Guys, let's keep tapping, tap, tap. Help me repost this live so I can have a larger audience. Help me repost. If this is your first time, kindly give me a follow. Good morning, everyone. You're welcome once more. Please help me repost so I can have a larger audience. Good morning, my beautiful people, beautiful ladies, handsome men, handsome boys, and beautiful girls. You're all welcome. Good morning, 2022. Sorry. Good morning, 2026 JAM aspirants. Good morning, 2026 JAM aspirants. Help me repost this live so I can have a larger audience. Thank you everyone for always coming up to support this live. It means a whole lot to me. Hello Morena KG, how are you? Morena KG, I want to give you data today. Remind me, send me a DM, I will give you data today. Let me give you 2 gig from my data. Morena KG, if you are there, after the live, send me a message, send me your contacts. Let me give you data. Hello Cizella. It's network, oh my sister. Network. Actually, it's not that my network was bad. I used Starlink to browse. So unfortunately, I don't have a solar to support the Starlink yet. So once they take the lights, the Starlink will go off. So I'm still working to get a solar for it. That's just disadvantage. Other network data are not reliable for me during life. It's not strong in my house at all. So I decided to switch to Starlink. And Starlink, if there is no lights, I can't browse. So as I took the light yesterday, I just logged out. So sorry about that. Good morning, everyone. I'm not taking log again, no. I want to take a new topic today. So I want us to agree on a topic. Amen, Morning KG. Thank you. Thank you. Pick a topic. I'll speak on that topic. Please send my device. What? I want to pick a topic. I want to pick another topic. I've done log for too long. Let me switch. I will come back to log again. I will come back and solve log again before the JAM exam. But I want to do a new topic today. I've been on log for like 3 lives now. So let's suggest a topic in the comment section. Let's suggest a topic in the comment section. Morning KG, please hope my screen, my board is clear. Please let me know. Guys, can we suggest a topic or should I pick a topic? Yeah, we have, okay, it's clear, thank you. Okay, let me see my question bank. Should I do probability today? Or should I do calculus? I want to follow my topics that I have here. Or let's do coordinates geometry. I should do calculus. I've done calculus before. I did calculus last month though. I did calculus last month. Magnesium, thank you for the gifts. Okay, let me do differentiation this morning. Let's do differentiation this morning. So let me pick questions on differentiation. Nigeria is my location. Okay. Okay, Cizella, I've seen your comments. So let me get some questions. I wanted to do gradients of a line before this, but let me just do this. Differentiation. Let me get questions on differentiation. Please, just a moment. I want to get my questions. Guys, please keep tapping on the screen so we can have a larger audience. So we are starting. So let's start with simple questions first. The first question here says, find the derivative of x. As usual, I have my options, right? Option A is 1, option B is 2, option C is 3, option D is 4, option E is 5. So find the derivative of x. Let's start with simple questions like this. So let me read the comments. Let's start with simple questions of this nature. We are required to find the derivative of x. Hi Bikash, we are solving jam past questions. We are solving jam past questions. Good news, thank you for the roses. Thank you. Alright guys, you guys should drop your question. Drop your answer. Let's solve. Let's solve. We have enough questions to solve this morning. What is the derivative of x? What is the derivative of x? So what do we do? And let me solve. I want an interactive. Okay, 1. Yes, we all got it. Thank you all for. Thank you. So from the first principle, we can get the derivative of x, right? So you say y is equal to x. So all you just have to do is whatever value you're giving, you say y is equal to that value. So we are going to use the first principle to solve this. So this y now becomes what? Y plus delta y is equal to what? X plus delta x. What am I using? I'm using the first principle to solve this, right? So what do I do from here? What do I do from here? Who can tell me? Please, can anyone tell me? Can anyone tell me what do I do from here? Y is equals to x. Y plus delta y is equals to x plus delta x. I can call this equation 1 and call this equation 2. I want to use the first principle. I also want to explain this step by step. In case maybe this just comes up in an essay question, you should know how to do it. In case you are asked to use first principle to find the derivative of x. So let's subtract. So what do? We subtract equation 2 from 1, right? Equation 1 from 2. So you can now say y plus delta y minus y is equal to x plus delta x minus what? Minus x. So in this case, y we cancel minus y, we are left with what? Delta y is equal to x minus x, we cancel out, we have delta x. Do you understand? This is from the first principle. So what do we do from here? What do we do from here? I should divide both sides by what? At this point, what do I do? Let's make the class interactive. What do we do? What do we do? I should divide both sides by delta x. Should I divide both sides by delta x? So that this becomes what? Dy dx is equal to what? Delta x. The x divided by the x is 1. So this is the answer. Dy dx is equal to what? The derivative of x is equal to 1. And you can even, let me read the comment section. Okay, you don't know calculus at all? Yes, that's why I'll be taking it step by step. I will just assume that the audience I'm taking don't understand calculus. So I will take it. Yes, good news. Substitution can also work. Substitution can also work any which way. So at this point here, so I hope you understand this. Okay, so I'm going to assume that my audience don't understand differentiation, so I'll be taking it step by step. Okay, this one is just, by the way, so easy, as simple as that. If you wish to take a screenshot, please kindly do. Let me move on to the next question. I think we'll make it a bit fast so that we'll be able to cover as much questions as we can, because I want to do differentiation in 2 lives, integration in two lives, 2 live sessions. So let's solve another one. Let me solve many questions related to this. The next one says find the derivative of x squared. Now this one is x squared. You can see it's different from the first question. First, option A is 1, option B is 2, option C is 2x, option D is x, option E is x to the power of 2. So let me solve. If this is your first time, kindly give me a follow. Please help me repost this live. Damnare, good morning, you're welcome. So what do? We are looking for a derivative of x squared. Open up my question. We're looking for the derivative of x squared. So you say y is equal to x squared. Always remember, whatever you're doing, you always begin with what? Y is equal to whatever you're doing. That's the first step. Don't forget. So what do we do at this point? Now this y now becomes y plus change in y is equal to x plus, then the x is x plus change in x. But remember there's a square here. So in this case, you have to square this. So now we have to, this is x plus change in x squared. So we have to open up this bracket. We know how to do expansion. So let's have a rough work here. Let me make it part of the solution. Let's open up this bracket. X plus delta x multiplied by x plus delta x, right? X times x is x squared. X times delta x is x delta x. Then delta x times x is what? X delta x plus delta x times delta x. Tell me in the comment section, what is delta x times delta x, guys? Frank, good morning. Good morning, everyone. Thank you for joining. Yes, it's a new topic. We are doing differentiation this morning. Thank you, delta x squared, right? Yes, we are correct. So this is, okay, so this is delta x. So let's put it in the bracket and put a square like this. So let's equate this, you equate it to the left-hand side. This is y plus what? Delta y equals to this. Okay, we can still simplify this. This now becomes y plus delta y is equal to x squared, x delta x plus x delta x. What will be the value? X delta x plus x delta x. Tell me in the comment section. X delta x plus x delta x, what do we have? I'm waiting. 2 delta x. Good. So this is plus 2. Did you say 2x delta x? Good. So this is 2x delta x, then plus delta. So I can call this my equation 2. Why this is equation 1. So can we do equation 2 minus equation 1? So let's do equation 2 minus equation 1. So this becomes y plus delta y minus what we have here, which is y, is equal to, now let's go to the right hand side, that is x squared plus 2x delta x plus delta x all squared minus what? X squared. That's what we have in equation 1. So let's see. You see, y minus y we cancel out, that's a 0. So we are left with delta y equal to, now let's go to the right hand side. X squared we cancel out minus x squared. We have 2x delta x plus delta x all squared. So before I continue, if you understand up to this point, can you tell me understood in the comment section or tell me continue? Girlie, I'm too fast. You say I should do small. Am I too fast? Please, guys, if I'm too fast, tell me so that I can slow down. So now we have delta y is equal to 2x delta x plus delta x squared. If you understand up to this point, please, can you tell me continue in the comment section, please? Just hold on. Thank you for the roses. I'm fast. Okay, sorry about that. I'll slow down. Okay, let me continue. So what do we do at this point? We divide both sides by what? We divide both sides by what? Delta x. So you divide each of the terms by what? Delta x. So in this case, you see, delta x we cancel delta x, right? And here delta x cancels out one of the delta x. So what do we have left? We have the y. Let me be calling the y there. Is equal to 2x plus the last term. What do we have left? For the last term, what do we have left? Tell me in the comment section. Tell me in the chat box, what do I have left? If delta x squared cancels delta x, what do I have left? Thank you all. We should go together. So I have delta x here. So this now have dy dx is equals to 2x plus what? Dx, right? So what do I do at this point? What do we do at this point? Can we now take the limits? In that first question, I didn't even take the limit because even taking the limits will give me the same answer. So I was even supposed to mention that I will. Good. So we can now take the limits as x tends to 0, right? Good. So this now becomes dy dx, taking the limits as x tends to 0 equal to, what that means is what? We are going, anywhere we see x, we are going to substitute it with what? Anywhere there is x, what do we do? So now let's take the limit of 2x plus delta x. 2x plus delta x. Oh, sorry, not as x tends to 0. I wrote as delta x tends to 0. Is delta x, right? Comment section. Is as delta x tends to 0, right? So this now becomes what? 2x plus, I have delta x. So delta x is tending to 0. So this becomes a 0. So 2x plus 0 will give me what? 2x. So we have the answer, right? So the correct option is what? Option C. Option C is the correct answer. Please, can you tell me, understood, if you understand what we just did here? If you understand what we just solved, can you tell me understood? If you don't understand, please be specific and tell me the points or tell me the step where you do not understand. Tell me the point at which you do not understand. Okay. I can see all your comments. Thank you all for your contributions. SpongeBob, you are welcome. Even if you don't understand, baby papaya, even if you don't understand, not to worry. I have enough questions we'll solve. Flavor, thank you for the roses. To all my gifters, thank you. You missed the class from the beginning. Not to worry, I have enough questions for us to solve. So if you want to take a screenshot of this, take the screenshot. Let's move on to the next one. Take a screenshot. Let's move on to the next one. You understand? Just hold on. By the time I solve 2 more or 3 more questions, you understand this. This is just for the first principle. So I'm taking calculus from the beginning because I've gotten a whole lot of requests for me to teach calculus. So I'll be taking differentiation and integration. Please, if you have taken a screenshot, let me know so I can move on to the next question. Okay, so I'm cleaning this now. So this is a different one now. Now let's go to question 3. Guys, please, is today's date 10 or 9? Find the derivative of 2x squared plus x plus 2. Find the derivative of 2x squared plus x plus 2. You know, I always begin with the simple questions. Then as we keep moving, as we keep moving, the questions become what's more complex, right? Thank you, Yefisu. Thank you. All right, find the derivative of 2x squared plus x plus 2. Can I start now? Can I start? Okay, I didn't even drop the options. Okay. So let me get started. So I'll try as much as I can to slow down while solving this. But please, if at any point, if I go 2 steps, I will ask, are you clear? Or should I just solve at the end and I will ask you guys for questions. Let me just solve. Let me solve. So is there need for me to drop options for this? I need to drop the options. Let me drop. Should I drop the options? Should I drop options, so there's no need? I should just solve. Should I write out the options? Okay. Some people have dropped their answer. Some people have dropped their answer. Thank you. Okay, so let's do this. First step, what do you say? You say y is equal to 2x squared plus x plus 2. This is, let's call this equation 1. So for equation 2, the y now becomes what? Y plus change in y is equal to 2. Now this is x. This x will now be what? The x will now be x plus change in x. But you have to square this. Why? Because there's a square here. There's a square here, so you have to square this. Don't forget the square here. Then plus, now this x now becomes what? X plus change in x plus 2. Now let's expand this x plus change in x. Though we have done that, we have done something of this nature in question 2. But for those that are just joining, let me show us how to do it again. This is x plus change in x squared. It's just expansion. So let me do a rough work here. This is x plus change in x appearing twice. X times x, x squared. X times change delta x, x delta x. Delta x times x, also x delta x, plus delta x times delta x squared. So this becomes x squared, x delta x plus x delta x is 2x delta x. Then we have plus delta x squared. So that means if you open up these brackets, if you expand these brackets, x plus delta x squared, you are going to be having x squared plus 2x delta x plus delta x whole squared, right? So now let's come here and substitute. This here we have y plus change in y, let me be calling it change in y, is equal to, now 2, the whole of this now will be represented with this, which is what? X squared plus 2x change in x plus change in x squared. Then you have to close the bigger brackets. Because these two here affect everything we have inside of these brackets. Then plus x plus change in x plus 2. Let me draw a line here. This is rough work. Let me indicate it so that you know this is rough work. Now, let's open up. These two here, we use it to multiply all the values inside the bracket. We now have y plus change in y is equal to 2 times x squared is 2x squared plus 2 times 2x change in x is 4x change in x. 2 times change in x squared plus 2 change in x squared. Then we have what? Plus now x plus change in x plus 2. Let's see, what can we do here? Do we have like terms here? Let me ensure this doesn't enter the next line. What can we do here? Do we have any like terms here? Are there like terms here? Tell me in the comment section. Yay, my comments are so much that can I scroll down? What do I do here? Do I have like terms here? Do I have like terms? So is there anything that can cancel out here? Anyone? Is there any value that can cancel out here? I don't think we have any. This is x squared. This is 4x change in x, but this one is change in x squared. Okay, I think we have 4x delta x and delta x. Can I add them together? Let me just read a few comments so that I know we are on the same page. So I'm reading comments. Let me see. If you have been with me from the beginning, If you have been with me from the beginning, hope this is clear. Hope we are clear at this point. I'm here. Okay, we add the like terms together. So I'm here. I'm just reading comments. I'm reading comment 4 delta x plus delta x. Yes, that's the like terms. Those are the like terms we have. Okay, so we have this is equal to 2x squared. So y plus change in y is equal to 2x squared plus, where are the like terms we have? This 4x dx and dx, we add them together. That gives us what? 5x dx, right? Then plus 2 open brackets dx all squared plus 2. Now this is our equation 2. Are we clear with equation 2? Are we clear with equation 2? Are we clear with equation 2? Tell me move on. Tell me move on in the comment section if you're clear with equation 2. How did it turn to 5? You said we can't do that? Okay, for sake of clarity, just watch. For sake of clarity, I will leave this step. I will leave out this step. I will call this my equation 2. For the sake of clarity, let's call this equation 2. Now let's subtract equation 1 from 2. That is equation 2 minus equation 1. Now, equation 2 is what? Y plus change in y. Equation 1 there we have minus y is equal to, now let's come back to the right hand side. We have 2x squared plus 4x change in x plus 2 change in x squared plus x plus change in x plus 2. Then coming to the right hand side of equation 1, that is going to be minus. Now you have to open up a bracket. You have to open up a bracket because this negative sign here will affect whatever is coming next. So what we have on the right hand side of equation 1 is what? 2x squared plus x plus 2. You will see that this negative will affect all the values we have in these brackets and changes everything. So now let's simplify. Y we cancel minus y, we are left with what? Change in y. This is equal to, now this becomes 2x squared plus 4x change in x plus 2 change in x squared plus x plus change in x plus 2. Now this becomes minus 2x squared. This minus now affects this plus here. And we know that minus times plus is what? Minus. This becomes minus x. Minus times this plus minus, then we have a 2 here. Okay, so now let's look out. What can we cancel out here? 2x squared we cancel minus 2x squared. What else can cancel out? Plus x we cancel minus x. What else can we cancel out? What else? Okay, plus 2 we cancel minus 2. I think that's all. So we are left with what? Change in y is equals to 4x change in x plus 2 change in x all squared plus change in x. So what do we do at this point? What do we do from here? Comment section, what do we do from here? I'm to divide both sides by what? Divide both sides by change in x, right? So this becomes, we divide each term by delta x, delta x, delta x. So doing that, delta x cancels out here. What am I left with? I'm left with 4x plus 2 delta x all squared becomes what? That becomes a what? If you cancel it out, what do we have left? Delta x, we cancel 1 delta x at the top. I'll be having what? 2 delta x, right? Delta x divided by delta x will give me 1. So what do I do at this point? This is the y, delta y, delta x. So what do I do here? To get the y dx, we are going to now take the limits as what? As change in x tends to what? 0. What does that mean? It means anywhere you see change in x, you substitute with 0. It seems the comment section is blocking the down part, right? Is the comment section blocking the down part? Let me come up here. So this is equal to 4x plus 2. Now this is delta x. I'm going to represent it with 0, substitute it with 0, because we are taking the limit as delta x tends to 0. So multiply this by 0, then plus this one here. Then here I have what? I have 4x plus 2 times 0 is 0. 0 plus 1 is 1. So what we have is 4x plus 1. So this is the final answer, because we can't solve further from here. So the final answer is 4x plus 1. Now let me go to the comment section and read what you guys have been typing. If you understand, tell me understood in the comment section. We are solving differentiation using the first principle. We are solving differentiation using the first principle. If you understand, kindly tell me understood. If you have any question, please kindly drop your question in the comment section. If there's any point where you don't understand, let me know in the comment section. I'm reading comments, please. I have over 200 comments I'm reading now. I'm using long cuts. If I use shortcuts now, you will say, some people will come up and say I'm using shortcuts. They don't understand. They want to know how to do it in case it's an essay question. Even though what we are doing here. Okay, deja vu. Would you want to come up and help us with the shortcut method? Deja vu. Are you still there? Send an invite. Yes, I know it's a long one, but if I want to solve this, I'm telling you, if I want to solve this, if I'm the one to solve it, not that I need to impact the knowledge into people. Not everyone knows how to do this. So I need to solve and pretend like you guys do not know it. Not everyone knows it. So we have to just consider others. Damilare, what is it you don't understand? Can you be specific? If you know you want to come up and explain to us, come up. Deja vu, do you want to come up? Come and help us with the shortcut method that you know. Who wants to come up? Send an invite. Who wants to come up? I'm waiting. Oh, I'm waiting to receive your invite. After I divided both sides, divided both sides by delta x, is that what you don't understand? I don't know a simpler method, but this is what I know. Okay, deja vu, you sent a request. Okay, let me check. Okay. So when we are solving questions and in the audience, I have one or two persons that have a shortcut method to a particular question, I accept. Hello, deja vu.
Good morning.
Good morning. Thank you for joining.
Yeah, I've joined this live before.
Okay.
Sometimes maybe last week or something.
Okay, thank you for coming back.
So the thing is, there's since it's jump, I'm not going to say it's not good to learn the log method.
Yes.
But since you said it's for jump preparation, so that's why I kept on saying that there's always a shortcut.
Yes, sure.
Because of the time.
Yes.
Yeah. So even apart from differentiation, even integration, there's always a shortcut for everything in mathematics.
Yes.
So for this differentiation, there's always a formula You said it's nx raised to power n minus 1.
Yes. Okay. You know why I use this, because I'm trying to impact the knowledge of first principle. Do you understand? But I get what you're saying.
I understand.
Okay. So you're going to help us
Yeah.
with that. Help us with the formula, right? With the shortcut method. So I should clean the board.
No problem. Yeah.
Okay. So anyone who wants to take a screenshot of this, please kindly do so, because I want to clean the board, please. Please, let's do that in 5 seconds. Okay, so Dejavu is here to help us with the shortcut method. Okay. Okay, the floor is yours. Kindly go on. You are not the tutor. All I'm doing here for you is to write on the board.
Okay, thank you.
All right.
So, we write the formula n.
Okay.
Then x, like big X. Make the X big.
The bigger one like this.
Then raised to power. Raised to power n minus 1.
Okay.
So that's just the formula. So anywhere you see x in any given differentiation to do. So any n is the power of you understand? Let's say for example, this 2x raised to power 2 is matching with the formula, which is the 2 is n.
Okay.
The power that is, it is n.
Okay.
So you understand now that anywhere we see x and the power is always n.
Alright. So that means for the first time here, this becomes the power here, which is 2.
So our power is n then, which is 2.
Yes. Multiplied by.
So what we do next is exactly that n, which is 2, multiplied by the 2 that we have, which is the exactly. Then we pull back the x. Then n, which is 2 minus 1.
Okay.
So we do it for the next one too.
Okay.
Yeah, we have invisible
1.
Exactly, we have invisible 1.
Okay, so what that means?
1.
The coefficient
So 1
of
multiplied
x.
by x. What do you say?
Okay, I said the power here is 1, right? That's what
1, yeah. Exactly. So if we put 1
times
multiplied by x, then 1 minus 1.
Yes.
Then the other one, since it has no x, that one has gone.
That's a 0, right?
Automatically, exactly, since it has no x.
Okay.
So from here, we have 2 times 2, which is 4.
Okay.
Then x minus x, 2 minus 1 is what?
Is
1, which is x. We can say 1. Then plus, so here, x raised to power 0 is 1.
Okay.
From indices.
Yes. Okay. So this.
So we have 4x plus
1
x
times
x or x exactly. X raised to power, anything raised to power 0 in indices is what?
1. So this becomes 4x plus 1 times 1 is 1, right?
No, hold on.
Yeah, it's correct.
Okay, yeah, it's correct. I lost it for a moment.
Okay. So thank you.
So that's all. So any other the differentiation we want to do that is just all this straight line differentiation that is not the one with chain rule or quotient rule or product rule. You can always use nx raised to power n minus 1.
Okay.
So for any other calculations.
Okay. Thank you so much, Dejavu. Thank you. Okay. So for my live sessions, even though I know I'm taking JAM students, after solving every question, I use the normal method. I act like, okay, I just pretend as if I just want to learn this topic. You know, when you want to learn a topic, you learn how to use the words normal procedure. You teach your students normal procedure before moving on towards shortcut method, right? So I get. No, I'm just talking to the audience, like in general. You understand?
Okay.
So anytime you're solving a question here on this live, we use the long method. That is, we use normal procedure to solve. Then I ask my audience, if you have a shortcut method, since our target is for JAM students, if you have a shortcut method, come up. For every question I solve, I have the shortcut method by the side, believe me. But because I want to make my class interactive, I ask my audience if you have, for aspirant or those that have written jam before now, those that have experience. There are some people I invite to my life that ordinarily they've written jam like 30 years ago, they are experienced, so they come to my life, they join, their days they join, their times they join. They come and help us with shortcut methods. So thank you, Deja Vu. You are now one of them. So thank you.
Thank you.
All right.
Welcome.
So guys, let's appreciate Deja Vu in the comment section. So thank you once more. So if you understand what Mr. Deja Vu has explained, let us know and let's appreciate him in the comment section as usual, right? So kindly note that I only pick one or two, maximum 2 persons at a time on my live session. Reason is because we are here to solve maths. If I have so many people coming up, it blocks the board. So just 2 maximum, and you can only come up when you have something to say, when you want to contribute. And after contributing, you can kindly take your leave. Thank you once more, Deja Vu. So I'm in the comment section now. I'm reading comments. Oh. Sorry, my device was overheating, so the application had to stop for some time. The weather is hot this morning. See, I'm sweating. It's from my end, though. It's from my end. My network is not bad. My device was just very hot, so the application just closed up. So, as you can see, I'm now using a fan to cool the device. I didn't put on the fan at first, and the weather is very hot. So sorry for that. Sorry about that. So we can continue.
One shortcut. I don't think you have reached the method, the chain rule method yet.
No,
I think
no,
the question
no.
just popped up from, I don't know.
No, this question actually.
Do you understand?
Okay, so that means the shortcut method we can use.
Looking at this question now, even with inspection, just inspecting it, you know that this is automatically a chain rule question.
Okay.
Because it's like it has 2 things together.
Yes.
So anytime you see the derivative that have things together, you automatically know it's like a chain rule.
A chain rule. Okay. Okay, if that is the case.
It's not like a linear differentiation. Linear that is on a straight line. Since it starts 1 over something, it's like a chain rule automatically. I don't know
as far as there's a shortcut.
You understand what I'm trying to say?
I get it. No, I get what you're saying.
Yeah, but there's a shortcut for it.
Yes, so we are going to use it. And you help us with it. Please just give me a moment. Okay. Let me get my power bank because light has been seized and my battery is down. Just a moment, please. Please, just a moment.
Okay, no worries.
Okay, I'm here now. Let me just plug in my phone so. Guys, please, during the course of the live, in case you just observe that I log out, just know that it's my device because I might be logged out at any moment because my device is very, very hot. Very, very hot. So, okay, so deja vu, where should I claim from? From the beginning?
Yes.
Okay, the floor is yours now.
So, chain rule, the thing is, in differentiation, you know, we must have some formulas that we have to know offhand without even checking the book. Okay. One of them is this chain rule.
Alright.
So the chain rule says that the y over the u multiplied by the u over the x. Okay. That's the chain rule formula.
The y over the u.
The y over the u multiplied by the u over the x.
Over the x. So using chain rule.
That is the chain rule.
Alright.
So from the equation, we can decide to say it is 2x, open bracket. We can decide to say y also is 2x, open bracket 2x plus 1 raised to power minus 1. Okay. To make it a linear equation.
Yes, okay. So now we find the y.
So from there now, let us say,
let u to be equal
let's say y, exactly, let u to be equals to 2x plus 1. Okay. Okay. So when we write it, that means y equals to u raised to power minus 1. Okay. I hope you understand.
Yes. So this 2x plus 1.
So from the first there. Exactly. So instead of 2x plus 1 now we have u. Yes. Just like substitution. Yes. Or replacement, or I can't remember. Yes. So from here now, we have to take the first one, which is the y over the u. Okay. That means we are differentiating y in respect to u. Okay. So if you differentiate that from the formula I gave you before, that is n x raised to power n minus 1. Yes. From that formula, so our n here is minus 1. Yes. Then x, which is our u. U now, exactly. Then we have minus 1, which is minus 2. Alright. So this minus 1 times u is minus u. I hope you understand. So we have minus, our dy over du now is now minus u raised to power minus 2. Yes, minus 1 minus y is minus 2. Alright, go on. So we keep that ourselves as we can say that one is equation 1. Okay. Yes, I can hear you. We can say the y over the u now. Yes. We can say that one. We can say that one is equation 1. Alright. Alright. So we now go back to the u over the x. Okay. Deja vu, help me check where I want to write now. Is the comment section blocking it or should I write up? Help me check. Is it blocking it? You can just write up by the side. Okay. Write up by the side. Okay. So let's go on. So we now go back to, since we have two things that we are going to calculate. We have the y over the u. We have done that.
Yes.
Then we have the u over the x.
Okay. Let me even indicate that.
That means we are now differentiating.
So this is the formula for the y dx bar. Are you there?
So that means now we are now differentiating. We are now differentiating u in respect to x.
Okay. So we are looking for the u dx now.
So, and our u is what? Our u is 2x plus 1. So if you differentiate 2x plus 1 using the formula, the shortcut n x is power n minus 1.
Okay.
So we have u to be 2.
U is 2x plus 1. So this becomes, so let's let the audience know how it is 2. Because the power here is 1. So this is 1 times 2, right?
Exactly.
1 times 2.
Yes.
Then
Raised power.
X to the power.
Raised power
1 minus
0.
1.
Exactly.
So we have to do step by step. Because some people will start asking, how did you get 0? You understand? Then
plus 0.
Plus
Plus
0.
that one. Since it's not having x, that one is 0.
So this becomes a 0. So this is equal to 1 times 2x is 2x, right?
1 raised power.
Raised to power 0. And
in this is anything raised power 0 is 1.
Is 1. So this becomes 2 times 1, which is 2.
So we have 2 times 1.
Yes.
Exactly. So now we have equation 2.
Alright. So
that
means
is the u over the x now equals to 2.
The u dx is equal to 2. Yes.
So going back to the formula, the y dx equals to the y over the u.
Yes. We have it here already.
Equals to the y over the u.
So now let's
substitute. Write it again so that they can understand.
Okay. The y
write it again. The y over the u multiplied by the u over the x.
Alright.
So looking at it, if you look at the y over the u, if you decide to cross it out, the u will cancel the u, so we still have the y over the x automatically.
Yes.
You understand? So we see that we can cross it out to make it the y over the x. Now to make it, what is our dy over the u?
Minus u to the
we
power
have minus u raised by minus 2. Exactly. Minus u raised by minus 2. Then the u over the x multiplied by what? 2.
Yes.
So we can decide to write it as minus 2 multiplied by u raised by minus 2.
Okay.
It's still the same thing, right?
Yeah, the 2 is coming first. The same thing.
Exactly. So let us now replace our u back to the calculation, which is we now have minus 2 into brackets. Exactly. We have minus 2 into brackets. Exactly. Plus 1.
Yes. The power.
Close bracket, this by minus 2.
Okay.
So this is a linear equation. You can start to change it back to the normal form.
Okay.
You can have minus 2 multiplied by 1 over, do you understand?
Yes.
Multiply by 1 over then 2x plus 1 squared. So to remove the minus 2. So you can also say minus 2 over 2x plus 1 squared. So it's still the same thing as what we got earlier with the long formula.
Yes. So
that's just it.
So that's the final answer. And we have with the first, using the from the first principle or using the chain rule, any which way we arrive at the same answer. Thank you, Prof. Thank you, Deja Vu. So guys, if you understand what Deja Vu has explained to us, please let's appreciate him in the comments section.
Sorry, do you mind if I chip in?
Yeah, sure. We are here to share knowledge, Prof. Everybody is allowed to chip in. All right, sir.
All right. Because in case of jam like this,
okay,
there's always a strategy I usually ask students to make use of.
Thank you. Okay.
They want to work out.
Okay, so
first off, I think
should I clean the board?
We should appreciate our tutor that just commented. So I don't know. It probably shouldn't take up much space.
Okay.
Since I think this small space that you have underneath should be enough to show.
Yeah, I would love to clean it. I would love to clean it so that they don't mix it up and think maybe it's the continuation or something. So my audience, for the screenshotters, if you want to screenshot, let's do that in 5, 4, 3, 2, 1. So I'm going to clean the board now. Okay, so Prof wants to help us.
So I'm going to I'm going out now, so I'll join you guys later.
Okay, thank you.
All right.
Thank you. Okay.
So,
Okay.
basically, what I just want to explain is what he has done, or in a way that you don't have to like write a lot of stuff like this.
Okay. All right. So, Prof, the floor is yours. The board is yours.
All right. So, let's rewrite the function again. So we've got y is equal to 1 divided by 2x plus 1.
Okay. Y is equal to 1 over 2x plus 1. Mm-hmm.
All right. So the first thing I would like to clarify is I observed a lot of people having doubts on how did the power become minus 1.
Okay.
So basically, we try to apply a law of indices. So I want people to think of it this way, right? If we have, let's say, 1 over x, to rewrite that, it will be x to the power of minus 1.
Okay, so this also be
I'm just like pointing out something. No, just wait. I'm trying to explain how we arrived at that power of minus 1 and the idea behind it.
All right.
So, for example, now, if we have 1 over x, for all the audience that they are listening right now, if we have 1 over x, indices allows us to write that x to the power of minus 1. So, look at this case here now. What we have in the denominator is 2x plus 1. Now, it's not a single thing. So that's the reason why that 2x plus 1, we put it in a bracket, and the power of minus 1, we return it then. So our y is now going to be open bracket 2x plus 1 raised power of minus 1.
Okay.
So you can write that.
Okay. So this is 2x plus 1 to the power of minus 1. All right, go on, Prof.
So now, for JAM students, time is very, very important. You don't want to write out the bunch of all this kind of stuff. So this is what we are going to do. When you have a case like this, we are going to use chain rule, but you don't need to write all the formula. So the first thing you do is that power, bring it down. So we say bring down the power.
Okay.
So you write minus 1.
Okay.
Okay. Now, next thing, what you have inside, which is 2x plus 1, differentiate it.
Okay.
So when you differentiate 2x plus 1, what do we get? We get 2 minus 1 times 2.
Okay.
Times 2.
To the power of
close
minus
bracket.
1.
Then rewrite that function. No, don't write minus 1. Don't write minus 1.
We have the minus 1 there.
I just said differentiate the inside.
Yes.
Yeah, minus 1. Yeah, so drop the power.
Yes.
That's dy over dx. That's what we already solving dy over dx now. Yeah, we already solving dy over dx. So the rule is bring down the power. So we bring down the power, differentiate the inside. So you can write it out here. Bring down the power. Bring down the power. Then the next thing you do, differentiate the inside.
That is the bracket, right?
Yeah, differentiate the inside.
Okay, let's call it inside. Okay.
Then the third one, return, that bracket with 1 lesser power. So return the bracket with 1 lesser power.
Now let me call these brackets instead.
So differentiate the bracket, then return the bracket with 1 lesser power.
With 1 lesser power. Okay?
So now these are the 3 things that we are just going to do. And we can do everything in one line. So we have dropped the power, that's minus 1.
Okay.
Differentiate the inside or differentiate the bracket. And the bracket is 2x plus 1. So when you differentiate 2x plus 1, you get 2.
Okay.
Now you return the bracket, which is 2x plus 1, but with 1 lesser power. So minus 1 minus 1 is minus 2.
Okay. So this now becomes minus 1, then 2.
Minus 1.
Then returning the bracket, that is 2x plus 1.
Plus
with
1
lesser power,
minus 2.
You are subtracting minus 1 from the power.
Exactly.
Okay.
Exactly.
Alright, so this becomes minus 2,
right? So
right?
we can now finalize this.
This is now
this is minus 2.
Open bracket.
Then 2x
plus 1
to
the power of
minus 2.
Minus 2. Okay.
And that's it.
Okay, and this can be written as minus 2.
So which we can now rewrite.
Minus 2 multiplied by 1 over 2x plus 1 to the power of 2. Okay, which is also equal to minus 2 times 1 is minus 2 over 2x plus 1 to the power of minus 2. JAM candidates, thank Prof. Me, I don't know this one. No. I'm just learning this one. Oh, let's thank Prof. I've learned this one. Oh, I've also learned something new that I can teach my private students. Okay, thank you so much, Prof.
What did you say?
I said I've learned something new that I can also teach my private students. Thank you.
Yeah, sure.
That was really helpful. Thank you, Prof.
At the end of the day, you
Yes.
And we also want to be very, very precise. And we can quickly also use another example so that people would see how it goes.
All right. If that's the case. So, guys, if you understand what Prof has explained here, please take note of these 3 rules I wrote down here. Okay? If you understand, kindly type understood or appreciate Prof in the comment section. Okay? So, let's see.
How did you get 2? We got 2 by differentiating 2x plus 1.
We got 2 from the second step. So, Prof, let me get another question we can use. Mr. Marcos is here. Good morning, Mr. Marcos. You're welcome, sir. Okay, so let me get another question. Good morning, everyone. Good morning, Mr. Marcos. Welcome, sir. Thank you. We have Prof. Marcos here, even though he has not indicated Prof on his profile. Prof. Marcos and Prof. Bibi. You're all welcome. So let me get... Hey, my question bank has closed, so I have to reopen it. Prof, please just give me a few seconds. Let me open my question bank again. Just a moment, sir. When the network is shut down. So, guys, if you have any question, please ask your question or ask Prof with respect to what we just did here, so you can clarify it. Oh. Prof, please just a moment. I'm here. Please, I'm coming. Where is it coming? So I want to clean the board. Hope we have taken note of this. I want to clean the board. Prof, I was thinking of doing mapping and function in the next class. I don't know, what do you suggest? Mapping and function.
Yeah, sure.
When we finish, that's when we are done with calculus. 474. Okay, so I want to get a question that we can use.
We can just come up with like a random one off the top of it.
No, I'm there. I'm already on the page. I'm there. Prof, I have this question that says, can we use square root of x minus 1 to solve this? We can, right?
Yeah, sure, we can.
Okay.
We can. Absolutely, yes, we can.
Right.
In fact, that's like a nice question.
Please, let me take a shot of this. Just a moment. So find the derivative of square root of x minus 1. Okay, Prof, the board is yours.
Alright, so we will still return back to our process that we just applied. So square root of x minus 1, we can derive that as x minus 1 to the power of half. Because roots means power of half.
So here we have y is equal to 1 over the square root of x minus 1. And this can also be written as, so this can also be 1 over x
Okay.
minus 1 to the power of half,
where is the
right?
1 over coming from? Where is
the
1 over coming from?
You know, my brain is still on that first question that has 1 over.
Okay. Okay.
So this
So
is
it should be y is equal to
x minus 1 to the power of half.
so x minus 1 to the power of half. Exactly.
All right.
So let's apply all the process again.
Okay, we bring down the power.
So bring down the power. Our power is half.
Which is half.
Yes.
Then we
So
differentiate the
differentiate
brackets.
the brackets. That should give us 1.
1. Okay.
Yeah, so that should give us 1.
Yes.
Yeah.
Then the last step. We return the bracket
we should return the bracket with 1 lesser power.
With 1 lesser power. So this is going to be x, returning the bracket, which is x minus 1.
So that will be x minus 1
to the power
with
of
power of half minus 1.
Minus 1. Okay. So this is equal to?
It's about half minus 1.
Okay. So 1 over 2 times 1 is still half, right?
So we just simplify this.
Okay. Then we have x minus 1.
2, then x to the power of
Prof, let's ask the audience to help us with the answer to this, to just make the class interactive. Audience, what is 1 over 2 minus 1? 1 over 2 minus 1. 1 over 2 minus 1. Do I have any answer yet? Minus half. Okay. All right, thank you. All right. So here we have minus half. Okay, Prof, let's go on.
Alright, so you can just rewrite this.
So this is
So that will be 1 over 2
yes
times
1 over x minus 1
over
to the power of half, right?
yes.
Okay. So this can also be
that
written
x
as
minus 1 can now be written with the root.
sir?
So 1 over 2.
1 over 2 times. So can I leave it as the square root?
X minus 1.
Square root, right?
Yes.
Okay.
Yes,
So,
please.
okay, so 1 times 1 is 1.
Finally, we should have 1 over
2 roots.
square root of x minus 1.
2 roots of x minus 1. Okay. So this is our final answer of dy dx. 1 over 2 square root of x minus 1. Thank you once more,
You're welcome.
Prof. Thank you, sir. Okay. If you have any question related to what Prof has just explained, please kindly ask your question in the comment section. Let's ask.
Alright, I think someone said, why is the square root not 2 y half? I'm trying to understand that because power of 2 is different from power of half.
Okay.
Power of half in English is normally a square root.
Yes. In indices, if you have square root of a, this can be written as a to the power of 1 over 2. Yeah, so I think the person is mixing square root and square. You know when you have square root of a to the power of 2, the square is what can cancel the square root that will give us a. So I think this is what the person is mixing up.
Okay. Alright, Moren Keji said, can the formula be used all the time? Yes, it can be used all the time.
Okay.
Absolutely, it can be used all the time. Even, it can be used all the time. It's the same idea.
Somebody is asking you that how do you differentiate the brackets?
Like a change. And the only area where they can be like a change is when we are looking at like sine and logs, because those ones have like an idea behind them. But as long as if it's what is it called? If we have a linear function or a quadratic function to a given power, we can use it. If you have a trig function, it will always work.
So someone is asking, how do you differentiate the brackets?
Yes.
All right. And the person asking how do you differentiate the bracket?
Yes.
If you didn't join us when then there might be a problem. Because differentiating the bracket means we are just considering what is inside the bracket as a function of its own and then we differentiate it. So in this case now we have x minus 1 and want to differentiate x minus 1. You differentiate one after the other. When you differentiate x, you get 1. When you differentiate minus 1, you get 0. So that's how we arrived at 1 as the result of differentiation.
It's because the person was not here from the beginning. I think the first 3 questions were questions related to this.
Arisoma said, how did you differentiate the dy dx? Where did the half times 1 come from? So you can see she wrote some rules on the side. Bring down the power. The power we had initially was half, so we put the power beside it. So that is how that half came there. And for the 1, we said differentiate the bracket. So our bracket is x minus 1. When you differentiate x minus 1, you should get 1. And that's how we arrived at that one.
Okay.
So let me bring an example to demonstrate that so it will be easier, because people are still asking why that one, which is the position of the bracket. So this time around, Miss...
Yeah, there is a rule for it. In fact, it is from the rule that we came about this. What we are just doing is just like something that is supposed to be faster. Instead of you trying to write the whole step involved in the rule, there is a rule. It is called chain rule. Some people call it function of a function. And the person that had worked it out for us before, I think his name is Deja Vu, he had done an amazing job applying it. So there is a rule. What we are just doing here is like trying to apply the rule as well, but we are just not writing everything about the rule.
All right. So
Yes.
thank you, Prof.
So Miss Aisha,
Yes.
if we can, instead of the x plus 1, x minus 1, let's do it 2x minus x, and let's see, maybe 2x minus, 2x minus 1, maybe.
Okay. So
Under the same question, but just...
you want to use this to explain to the audience how to do differentiation, right?
Yeah, rules of differentiation, as long as you apply the right rule, you can be going through different methods and you still arrive at your answer. There was a particular question that we solved before this. If
we use 3 methods.
The quotient rule for division.
Yes.
The person will still arrive at the answer.
So let's do it 2x squared minus x, or minus 2x, 2x squared minus 2x.
Okay.
Yeah, or maybe minus any x.
It's because these people are just joining. Like we've solved so many. In fact, I even stopped numbering the questions. We have solved so many questions this morning, teaching how to differentiate. Deja Vu even helped us with the formula, right? Yes, he helped us with it. Mr. Marcus, kindly go on. So for the people asking about this, Mr. Marcus, are you there, sir? Hello, Mr. Marcos, are you there? Hope it's not my network, or is it muted? Okay, it's muted. Okay, it's muted. Okay. Okay, Prof, maybe you can just carry on pending where Mr. Marcos is back.
Okay, then. So I think we should quickly try to explain that differentiating the bracket again so that people will understand.
Okay. All right.
As I think the person that explained it before should take it since it's back. Yeah.
So
you can.
Welcome back, guys. So the thing is, from this derivative, I've explained earlier that there's a formula, a very short formula for you to differentiate a function.
Yes.
Faster, even without writing it down, you can differentiate a function.
Yes.
Mere looking at it. From this derivative, 2x squared minus 2x, applying the normal xn minus 1, you should be able to solve it even without writing it down. So that is what I want people to learn. Even without writing it down, you can solve it.
All right.
Just by inspection. So people should understand that I said when we have a power, we have that is the n. So from this first one now, the power that we have here is 2. And the second one, the power we have there is an invisible one, like I've explained earlier.
Yes.
So you can just write it there to be 1. So that you understand.
Minus 2x to the power of 1. This is the same.
So just by applying the n into bracket nx n minus 1,
Yes.
you should know that our n is 2 here.
Yes, 2.
Or let's do it like this. If people sees a derivative, just first thing you find is your n. What is your n? Since you know your n, just apply the formula. You'll be able to get even without writing it down. So let us solve this one with the shortcut.
Right.
So we have 2 multiplied by, what is our n?
That is x.
Our n there is 2.
Now we have the x.
Then multiply by the 2 that we have there. Then, no, hold on.
Okay, multiply by this 2.
We have 2 before.
Yes, we have a 2 before. Okay, let's...
Exactly,
maybe
multiply by this 2.
Mr. Deja vu, sorry, maybe we should make this one 4 so they understand better. They should know that,
Okay.
there was a 4 here. Yeah, it's still the same, yeah. Just, some people will be like, maybe, some people might start thinking maybe you have to multiply the power 2 times. Do you understand?
Okay, understand.
So this now becomes 2 times 4.
Then x, then what, n minus 1, which is, the n that we have there is 2.
Yes.
Then that is 2 minus 1.
Yes.
We'll go to the next one.
Yes.
Then we have 2, the 2 that we have there. Then x into power 1 minus 1.
No, we have to multiply the power.
You know we have 1, 2 there.
Yes, the power is 1. Right?
Let's say, okay, 1.
So
1 multiplied by 2.
Yes, so the power multiplied by 2, then x, then the power 1 minus
then 1 minus 1. So that's just it. Then we have 2 multiplied by 4. That is 8.
X, then
8x raised to power 1 minus 1 times 2, which is 2. Then x raised to power 1 minus 1 is 0.
0. So this is 8x.
So here we have 8x
minus
8x minus then 2
times.
In indices, anything raised to power 0 is what? Is 1. So 2 multiplied by 1. So we have dy dx equals to 8x minus 2. It's as simple as that. Someone is asking where that 2 multiplied by 4. It's not 2.4, it is multiplied. People don't understand that dots is multiplication.
Yes, so people, yes, if it was a decimal
people
point,
are saying 2.4.
No, this is 2.1, then this is 2 times 1. See the difference? They're not the same.
People are asking.
Yes, they're all the same, please. But Deja vu, from the solution, we forgot this.
You can drop the question with the tutor.
Eh? Sir?
Someone is asking, can I drop a question? I said, the person can drop the question with you.
You can drop your question if it's related to the topic we are solving. If it is related. But if it's...
Because someone is asking that the square root, it has not been differentiated.
Yes. That's what I was trying to mention to him. I wanted telling him that we've forgotten this square root though. But maybe we'll just take this question like this, then we can resolve again and introduce the square roots.
Okay, so it's down.
Yeah, let Mr. Marcus undo everything with the roots now. I think he's just trying to clarify that differentiation. You know, people kept asking.
Yes, I get
it. Bracket, how the differential bracket,
yes.
how the differential bracket.
Okay, so please, can you clean and let's start all over with the square roots?
Okay, so,
well.
All right.
Let's be sure. I don't think anyone is still having an issue with the differentiation anymore. I'm also trying to go over the comments so that it should make it easier that way.
Okay, so I should introduce this.
Is everyone okay with the differentiation now?
Oh, Dean Black said, please, where is the 2 multiplied by 4 coming from? There is already a 4 in the actual function. That 2 is the power that x had. So you use that power to multiply 4. So that's how we get it.
Okay, so please, can we start all over so that we'll handle that?
Okay, this will be the last question for today, because my battery is down. There's no lights, unfortunately, and my battery is down. Okay.
So before the y, please, you clean the question. Let's deal with the differentiation with kind of the way of understanding. So let's have ax squared.
Okay. Ax squared?
Yes.
I should write
ax squared. plus bx. Let's say plus c.
Okay.
Plus c. We are just using the quadratic something.
All right.
So let's assume we have this, okay, and we are differentiating this, okay. First of all, know the powers because we are doing by the y the x, okay. It means that we are working on the x, okay. So you have to multiply the initial power of x by the coefficient of the x, okay, or wherever you find x. Wherever you find x, so let's assume that the c, which is a constant, because it has no x, let's add x raised to the power 0. Okay. Let's add x raised to the power z.
Okay. So this c becomes x to the power of 0.
Yes. So that we have all the x's with, from the highest degree to the, no degree.
This one
okay.
Is to the power
so
of
to
2,
differentiate.
1, 0.
Good. So you have to multiply the power of x by the coefficient of whatever the x is. Okay, so the first term we have there is ax squared. It now becomes 2 times a because the power is 2.
Okay.
2 times a.
Please,
then we subtract 1 from the power. So please, let's do that. 2 times a.
Sorry, let me plug in my device. It's about to go off. The light has been restored. Please just hold on. Please just hold on a moment.
Okay.
It's not even charging because the device is very hot. So I will have to stop after this question. Okay, Mr. Marcus, let's go on, sir. So this becomes 2 times
A. So 2 times a. Then the x squared, we subtract 1 from the power.
All right.
Then we go to the next step. Now the next term, because we have the coefficient of the x to be is b times the power, so 1 times b.
Yes.
Then we subtract 1 from the power, which is already 1, so minus 1.
Okay.
Then the c, there's the same thing. So please, what do we do to this one? Everybody, follow what we've done so far. So what do we do? Since the power of x is 0 and the coefficient of that x is c, what do we do? Audience, just follow what we've done so far. We multiply the first term by the power of the first term by its coefficients.
0 times.
Okay.
Not c times 1, oh. I think it should be 0 times c. Maranikaji, the power there is 0. Okay. I think they've responded.
So it's 0 times c.
Then x to the power of 0 minus 1, right?
Yep. Good. So this is what we do. So please, I hope you are following. This is so straightforward. Just multiply the power by the coefficient of the x term. Okay. Yeah, so let's simplify now.
All right.
So we have 2a
x.
2 minus 1 is 1. So the power, we subtract the power there. So
that is 1.
Then b, instead of 1b, we have b.
Yes.
X raised to the power 0.
Yes.
Okay, then plus 0 over x, because x raised to the power negative 1 is the same as x. Okay. So please write plus 0 over, because 0 times c is 0. 0 over x. Yes.
Mr. Marcos, I think you should tell them that this x is x, then 0 minus 1 is minus 1. Now, I know what you're trying to do. You want to bring the x as a denominator.
I mean, that is...
If you do that, some people will mix it out and might not get y.
Okay, no problem.
Okay, let's go on, sir.
So we simplify. So we have 2ax.
Okay. 2ax plus
plus b plus b
yes,
plus 0.
plus b times 1. Let's let them know that x to the power of 0 is 1.
Oh, okay, okay.
Because some
Yeah,
will be
so
asking where
I
did
mean,
the x
continue
go
from